we are going through each and every step. So now is the part we are discussing the tech stacks and the technology and architectures and the code standards were used in that project. We will go through each and every steps, and then we will check where we are standing. So for the deployment, first of all, I will go to the Visual Code, and here is our README files. We have the Git repo, and we have the proper README file here, which cover all the aspect of the game. What game is, what tech stack we are covered, what how to run it on locally, how to see the deployments, and how we handle the things. Each and everything is mentioned in that file. So we will go through one by one in this through this file, and then we will check the code base as well. So I have added the live demo link at here, so anyone can check this link from the live demo link. So as I explained, the this game is like this is a card game, and we have to bet that is the number is higher or lower and all that stuff. It's also described at the top level of that README file. So I'm going forward with tech stack information. So uh, this is the this is a gameplay which involve mostly the front end logics, where we will compute the numbers and dynamically show the cards and all that stuff. So mostly our logic is on the front side, and we need a proper UI that reflect and attract the user and make the user experience very good. So I choose the Angular 17, where, along with the Prime NG 17 and Tailwind CS, which make the UI more attractive and responsive. So I use the Angular for the front end, and for the back end I use the NestJS 10, and for the database I use the MongoDBs via Mongos. And these are the tech stacks here, and again I will go through the structure of the repo later. And we have also added the test cases for the backend. So we have created the APIs, so we will create the test cases for that to test it's working or not and all that stuff. This is the testing parts, and then we have the regarding CI/CD pipeline deployment. So we have the I have maintained the Docker files in here in the code, and use these Docker file in the render server to deploy that application. So I use the two services. One is the API that uses the Docker file and publish that API service, and one is the static application that will publish the front end of that game. So so this is the whole deployment part, and also I use the MongoDBs for the database on the deployment side. So this is all our tech stacks and our deployment scenario. Moving forward with the repositories layout, how we structure the things, which things is where. So it's very important when we build an application or a game or anything. It's very important to place the thing at its right place. If it's not, it's very difficult to identify, and it's very difficult to extend the features in the future. So keeping in mind that we need this code in the future, and this should be clean, and this should be uh, in expand the code functionality. I'll manage that structure. So we have the uh, parent folder like handwritten game. In that we have the app folder, libraries folder, doc folder, GitHub files like CI, YAMLs and lint and all that stuff. We have the Docker files for the APIs and the webs, and this README file. This is the our parent folder, which contains the high level files plus folder. So so our main main folders are the app folders and the libraries. So in libraries we have the shared folder, and in shared folder we have the types and game engines. So as you see on the screen, in the game engine we will separate the whole rules of the game in that game engine. So we don't need to go through each component in the Angular to identify the logic and change that in the future. So all the game rules are separately placed in the game engine folder. We have a separate file for the game engine. So whenever we will change, we are noticing some changes or want to change any game rule, we are not going through the each and every file in the code base and in the component and check that what happens, and then we do not need to do that. We just go to the game engine and update that rule. So this is the shared location where we'll manage these things, and all the shared types, game states, DTOs, and all the game configurations are placed at this level. And in the again on the apps folder we will separate the front end and back end. We created the two folders, web and APIs. In the web folder we created the Angular app, and the web API folder we are creating the Node.js apps, and create the components in the Angular app, created the pages. I will go through the like in the files after that, covering this whole information in that file. We can review that as well afterward. So this is the repository layout. We will moving forward with the next step. So next we have the some instructions for the any developer who need to run it only local. So whole step is like we will mention that whole steps here. We do not go to the details at that point. So moving forward, uh, next we have the environment variable. So we created the environment files, and we placed the database connection string in the environment files, and the port that that we need to use. By default it uses 3333, but on different systems we facing multiple problems, like the that port is like not available or blocked or anything. So we need to change that port. So if it's happened, like if anyone trying to run it on our their local and facing some port issues, he or anyone can put that port in the environment variable, and it will use that port. So by default it's using 3333. So right now we don't have any a lengthy environment file. We are only included the two environment variables here. I already one important thing in the architecture. So I made this thing like we created the Node.js like multi-tenant tenants system. So we if we need multiple copies, like multiple deployments for that game for a different company, so we don't need to do anything in the code. We just need to deploy the front end on a with a different subdomain or a different domain, and pass that domain, that tenant in the environment variable, and the backend remain the same. So we added the tenant ID at every level. Like we are handling this on the front end, we are getting the environment variable of that tenant and passing it to the headers of the API, and then API will use that. And but API will like APIs will use that tenant ID or pass that tenant ID into the DB. So in the DB level and in the schema, we have the tenant ID in every table. So we do not worry about if we have a second client. So we don't need to deploy the backend and the database again, and the create the copy of that database and a backend. So our database is same, our backend is same. Just we need to replicate the front end. So here is the important thing. Also, while talking about the architecture, one interesting thing is like we have the some preconditions, some configurations here in the game. Likewise, we have let me open the game configurations, and we will see. Yeah. So these are the game configurations so that need to be there to run that game. So these are the these should be different for different clients. So hand size, what's the hand size, like 3, 4, 5? What is the hand size? What the score that when a user win the bet, what's the score, and if the lose, what's the score? So these are the mainly configuration here. So instead of hard coding that in the repo or creating any environment file or any TS file and hard coded in the repo, I'll create a database table, and database table include all these information along with tenant ID. So right now we have the tenant ID default along with all these information, their default value like 5 as we see in the gameplay. So this is the handle at the DB level. So whenever we have the new tenant, new client, we just need to add one single row in the database, and where new configuration is updated. New configuration is added for the new client. And if anyone needs to change this preconditions for this client by for he don't need to go through the codes and edit that code, find the exact place. Is it used at one place or a two place or a three place? We don't need to do that. We just need to update at in the DB. We don't need to update in the code and push the code and then deploy it again. Nothing. Just need to update the database and this will be working fine. So this is the most important part, I think, for the future extensibility and for the multi-tenants scenario. So this is the this handles at the DB levels. So this is all about the architecture. So at later we have the API endpoints. In the API endpoint, we have created multiple endpoints like API games. We need to game ID and the player name. We will create the when user enter the username and click on the new game, then we need to create the ID of the game in the database to set the records and all that stuff. We will create that entry in the DB. So when the game is completed, we updated the score, hand players, and all the stats in the database. We need two APIs here, and one for the a landing page where we list the scores, top 5 scores at the dashboard. We need that API as well. So we created that API, and also we need the as I discussed, the game configurations are handled at the DB level. So we need the one API for that game configuration. So we added that. Also, I have added the one API is like API help. So when we deploy on any server, so we need to check if our APIs are live or not. So I will create a basic API for the API health, which will return the status and uptime. This is important because you see, someone said that we have the multiple APIs, we will check the other APIs, but in the real scenarios, the other APIs have the restrictions. We have particular headers, particular authentications, middlewares. We have the payloads and all that stuff. So, it's difficult to check those APIs, and on the production level where we are not able to hit those APIs as well. It gonna like if it's the post API, it will cost you. It's a production data. So this is the health check API. We have added that which will give the status and uptime. So we will understand is the our API is live or not. This will indicate go through the repo. After that, we have one more important task here, like we need to seed the data on a first run, like if we don't have the migrate like DB, we create the database and create the tables and seed the game configuration data into that table. So as I show here, we have some default value. So when we run the application, the seeding process is run, and it will create the table and feed these default value into database. So this is the seeding process is already implemented in the repo. 1 second. Okay, so